Hey everybody, this is Larry. This is day 10 of the July Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, Decode Waste 2. Okay. I mean, I would say, well, one is I usually solve these live, so if it's a little bit slow, fast forward, do whatever you need to do. Yeah. And join me on Discord, because if you like, today's the contest day, so right after the contest we go over problems and just have fun and so forth. Today's problem is Decode Waste 2. So this one is dynamic programming. It's a very well-known dynamic programming problem. If you're a little bit rusty or whatever, this is definitely a given one. And I'm not gonna lie, one of my colleagues, whom I respect a lot, that used to be one of his interviewing problems. So it is a thing. So definitely, you know, mod. So definitely keep that in mind. And it is a problem that some people do as an interview. So anyway, let's see which variation is this, because there are a couple of variations, and basically this one, there's a star character and digits. Okay, so that doesn't seem so bad. Okay, so it's star. Oh, and there's a. Okay. So basically, to be honest with these problems, very often it is going to be just being very careful with all the cases, because if you've done enough dynamic programming problems, especially enumeration counting ones, then this is actually not that bad. It's just about being careful and getting all the edge cases and all the cases, which, to be honest, sometimes I do not get all the time. But yeah, okay, so let's go through it. So I'm going to do this bottoms up, keeping in mind that I am going to do this with O of n space. You can optimize this to O of 1 space pretty trivially, actually, but just going to do that for now. Let's set this up, and then now we will go from left to right. And in this one, I think it's a little bit easier. Usually I do it top down, to be honest, to do it one digit at a time, but here we can go from left to right and just look at the last one or two digits, and then kind of get the prefix. So then you can just get the prefix, the number of ways to do the prefix, plus the suffix of whatever you, or like the last couple of digits. So let's do that. So dp of 0 is equal to 1. Let's actually set this to do +1 so that we can get it. So 0 is the 0th digit. So one thing I would say with these, and you can set it up however you like, so you may see different variation of this, but the way that I think about it is, okay, well, let's get it. Only 3 examples. Okay, well, let's say you have some number here. We'll skip star for now. But yeah, so my indexing is actually not the numbers itself, even though obviously there's a correspondence, but the spaces between the digits, right? So then here, my 0 is the number of ways that there are 0 characters. And for 1, there's number of ways that 1 characters, and so forth, and also there's 1 at the end. So then, and our dp of 0 is the number of ways that are after n characters, right? So that's basically how I set this up, and that's how why my dp has n+1 spaces, right? So okay. So then now let's go for indexes range from n. What does this mean? So this means that so how many ways are there for there? So dp sub I equals to the number of ways to n on the ith space, right? Which is the space. When I say space, I mean this spot, right? For example, so number of ways after the 0th space, the 1st space, and so forth. So that's basically the way I would say it. So now we enumerate all the possibilities. So, okay, if, oops, this is actual code, as sub index is equal to, so there are only a couple of cases, right? So, and this is something that we have to enumerate. So basically we go, okay, if this is, let's start with 1 digit first. If s of digit is, yeah, if it's between 1 and 9, right? Keeping in mind that with 1 digit you cannot have a 0 because there's no leading 0, and because a is maps to 1 for some reason instead of 0, but it is what it is. So if this is the case, then dp sub index is equal to dp of index. Oh, whoops. This is a little bit awkward. You just have to be careful, because db sub index is not the same as the string of sub index, right? So this is actually dp sub index plus 1 is equal to dp of index. Yeah. And that is correct, right? I think this is right, because this is the case of if there's 1 digit, then yeah, this is just 1 digit. Okay. Well, if it's 1 digit, we can also check that if index is equal to star, then what happens? If it's 1 digit and it is a star, then it could be any one of the 9 numbers, again skipping 0. So then we do pd plus 1 plus or minus 9 times dp of index, because it could be any of the 9 possibilities, right? And of course, at the very end, actually, let's change this now to dp sub n. We should actually mod it along the way, but I just want to make sure we get it right first, because I made this mistake before where I forgot it later. So it's okay. So let's actually do it now, because I sometimes I forget. Okay. So that's 1 digit, and I think I took care of all the 1 digit ones. Is there any other 1 digit numbers? No. So then let's do the 2 digit ones, right? Yeah. And if index minus 1 is greater than 0, something like that, is that true? Yeah. Basically, we just want to make sure that there are at least 2 digits that we can count, then we check, right? If we have at least 2 digits, then okay. What are our cases, right? And this one is a little bit enumerative, at least the way that I do it. Maybe, at least the first time, I would just try to be exhaustive and try to figure that out. And then maybe optimize the if statements later so that you have fewer if statements as you generalize the case. But again, correctness is what you should aim for in the beginning. So that's basically what I would do. Okay, so now, let's just say previous is equal to s of index minus 1. And that's actually just said now is equal to s of index, or current maybe, so that we just keep things a little bit straightforward. And stuff like that is just kind of for me and as an alias, so that I don't kind of mix up with things. But yeah, so what are the possibilities, right? Well, you just enumerate them. If previous is equal to 0, then nothing happens. Now we're doing 2 digits, right? 2 digit numbers, 2 digit possibilities. So if it is a 2 digit number starting with 1, then dp sub 1, let's see, right? And then now we have only one thing again. If 0, then there's basically the 10. Oh no. Well, yeah. Basically, there's only one possible. If the previous digit is a 1 and the current digit is 0 to 9, then there's one way to kind of lop that off. We just lop off 2 characters, and that's basically how we do the counting. Okay. Else if, I guess this could be an else if, but it doesn't really matter that much because if they're mutually exclusive, it doesn't really change, right? Otherwise, if current is equal to star, what does that mean? Whoops. That means that it could be any one of the 10 digits. So then we do something like this because there are 10 ways to do it. And the reason, just to kind of go over this very briefly, the reason we have this is that we can, this is kind of a shortcut. What you would do maybe is actually something like dp index plus 1, same as we have here, but then we would do this 9 times. And you could say, okay, if we substitute, I can't spell, substitute as a 1, if we substituted 2, and so forth, right? And that's basically the idea here. But yeah. But instead, obviously, there's 9 of them, so we do this. Yeah. So yeah, so here in this case is the same because we have 1 for 0, 1 for 1, 1 for 2, 1 for 3, 1 for 4, and so forth. Okay. And that's pretty much the same else for this one. But if previous is equal to 2, then we go, okay, if 0, then it is a number between 0 and 6, and there's 7 of these. But yeah, and of course, this is the same as before. It just counts for one of them because now you lop off 2 digits. You're able to lop off 2 digits. Otherwise, if current is equal to 0 or star, then we have 0, 1, 2, 3, 4, 5, 6. So 7 of these. I think I messed up this once before because of this. You know, last time I did this, I might even have a video. I don't know if I do, but I think the last time I did it top down. I vaguely remember it, but it's been a while, right? And then the last possibility of a 2-digit number is if previous is equal to a star, right? If this is equal to a star, then again we just go for all the cases of if let's see. And this is, of course, a combination of this and this, so we can actually just copy and paste, I think. This one's a little bit sketchy. Yeah, because that means that the previous number can be, say, as 1 or a 2, and we just kind of do the math that way. Because we can lop it off assuming that the previous number is 1 or a 2. And yeah. And then the other one is, I guess this is not an else if. Otherwise, if current is another star, then dp of index plus 1, then we lop up 2 digits, but the 2 digits has 26 characters, right? Because it could be any one of the 26. Also, I made a mistake here. This should be -1 because we're still chopping off 2 digits. I don't know why I did that, now that I think about it. And that's pretty much it. Well, except for this is wrong because we've been updating dp index plus 1. But yeah, let's see if this is right. This feels a little bit awkward right now. Oof. Did I miscount something? Well, at least the good thing is I'm wrong on 19, which is pretty good. Why am I wrong? Because that means that I'm off by 1 on one of the countings. Why is this not 19? Well, so it could be one. So it's one digit. That's the hard part about these problems, is that you really have to make sure all these are correct, but sometimes you're not. Sometimes you're just not right on all of these. But okay. But it seems like the good thing is that when you get something really easy wrong, then you have an easy way of debugging it. Let's see. So if the previous is 1 and this is current, then is equal to 10 times. So we did summation of this and this is y. Is that wrong? Was there 10 digits? Or 10 ways to interpret this? Did I mess up here? Why do I think there's 19? Dun dun dun. So yeah, so it could be any one of the 9, that's right. Oh, is there no zeros? Okay, maybe okay. Okay, so 0 is excluded for some reason. Huh. So, okay, so I just misread the thing, which is good because otherwise I'll be a little bit embarrassed going through this. But it is annoying. I need to be better about reading, to be frank. But why is 0 excluded? That's just a weird thing to remove. But okay, so let's go through it again then. Obviously now there are no zeros, and obviously in this case, well, this cannot be 0 anyway. But here, that means that we cannot fill in 0, so we have this, and what does this mean? That means that this is not 26 anymore, right? That means it's 26 minus 10 and 20, so that's 24. Okay. Okay, so this looks good then. Okay, so got me worried that I missed something really obvious, but I'm glad that this happened. One thing that I would say is that I am, to be frank, very sloppy with the modular math. If you're not in Python, I do this because in Python it doesn't matter as much because it has auto promotion, and as long as you mod within reasonable amount of time, you don't get you don't get overflow. But if you're in different languages, I definitely recommend modding after every adding. I would even let me give it some minute before I forget. I would even ooh, why didn't I test this? Okay, that's fine. I guess I should test more. But yeah, I would even, what was I going to say? Yeah, for different languages, I would even have a big nums class. Well, not a big nums class, a modular math class. Just do it once so that you can understand all the implications and test it so that you don't have to worry about it in the future, especially if you're into competitive a bit. Okay, so I am getting wrong the case where the 2 stars in a row. So it seems like I am wrong here, which is fine. It's not a big deal. But, why is this not 24? Dun, dun, dun. I mean, clearly, I think I just have this case wrong. But again, this is just enumeration, so you can just think about all the possibilities. And again, I really should have tested this because this is very obvious example, but I got a little cocky as I was talking about it. But why is this wrong? So it's just that this number is wrong, but what should it be if it's not 24? Oh, I am dumb. Okay, it's not 24 because it also doesn't have the 0, 1, the one digit one. So I got lazy. I said 26 minus 10 and 20, but it's actually 26 minus all the one digit ones, which is from 1 to 9. Well, yeah, 1 to 9 plus 10, and so then we have to subtract another. So okay, so that's how many is that? Let's double check. 11, 12, 13, 14, 15, 16, 17, 18, 19, 21, 22, 23, 24, 25, 26. So 15. Right. So these things, like I said, it's very simple. It's just you have to be okay. See, there we go. Whoopsie daisies. A little sloppy there, for sure. But that said, it's not hard. It's just that you have to be careful. Oh my. Oh, because I thought you can't get a 0 in this. Oh, this is very annoying, to be honest. Because, well, this one, maybe I just misread. Because I feel like this one's the trick cases. Wait, I don't, okay. This one's a little bit confusing with its handling of 0, but like I said, so the actual algorithm, it's not that bad. It's not that hard, I hope. And I hope that you understand it. But I am running into some technical difficulties. Because of understanding the problem, which is another problem. But that's another story. So is it just that if there's 0, we just don't hold it at all? That's really awkward, though. So star can be any from 0 to... Oh no, well, I think I just misunderstood. Okay, maybe I misunderstood this one still. So there can be 0s to 9s, it's just that the star cannot be that. Is that right? Okay, so let me fix this again. So there can be 0 and whatever. And in this case, we have to handle the case where the last digit is a 0. And the reason why this is invalid is because... Wait, why is that invalid? Can this all just be 1s? I think I just don't handle 0 correctly because I tried to fix it and then I thought that 0 is not possible, but I was wrong on that one. Sloppy, but okay. Let's see. And I'm doing a little bit of cheating by having some cases here, but I'm trying to understand why this would be 0. Oh no. Why did I... Oh, I misread this output. Okay. I am having a fun day, a fun morning. It's too early in the day. But I read that as the expected output is 0 and what we get is 4, but it's the other way around. Okay, so then we can fix that. And we kind of fixed it a little bit by adding this 0 and 9, but it seems like we overcount already because... So star and 0... So star and 0, yeah, we just lob it off. We lob it off twice. So why is this 11? Oh, this is 11 because we have 1 digit, and then we always assume that the last one have 1 digit, but that's not the case. Oh, this is not true. That's why. Okay. Just have to be really careful. It's very precise, as you can kind of see now. Okay, this is good now. And as you can kind of see, you have to be really precise in all these. The reasons why I just kind of absent-mindedly changed all the ones back to 0 to kind of fix it, but I didn't really go through the cases, right? What I should have done is go through the cases, and for 1-digit numbers, we cannot have a 0. So that's why here it should be still from 1 to 9, where here it could be from 0 because in 2-digit cases, the second digit could be 0. Okay, let's give it a submit again. Okay, I think this is more right now. I should have tested more as well still, but I was sloppy and I don't know. Okay, cool. So this is accepted finally. So I think, as I was saying, the hard part about this is about just enumerating all the cases. You can maybe clean this up a little bit, the code, but the idea is still the same, which is that you just have to be really careful and really think about it. think about all the cases. There's nothing that tricky about it in terms of that. I mean, okay, there's something tricky maybe you want to say with respect to how to handle zeros and so forth, but that's something that with enough time you're able to solve. There's no high level wizardry. There's no like crazy algorithm that you have to do. But yeah, it's just me literally being really careful, and in my case, not being very careful, but still eventually going through all the different cases. Again. The other thing I would urge is just be careful with the mods. You should mod after operation. So it might seem like that I'm doing it kind of haphazardly with respect to mods, and maybe I should do its own separate video explaining numbers and how they get stored and why you need to do mod and how to do mod correctly in a lot of cases. I do it in a sloppy way because I know exactly how to get away with it and how to fix them when things come up. But definitely do some reading up on it. I don't think it's that important, to be honest, in real interviews, but for competitive programming, it does come up quite a bit. So if you learn to do it once, you're pretty good for the most part. I would also say that when I change back to C++ or something, a lot of my mistakes are because of using int or long or mod. So even I make these mistakes a lot because I'm not as careful about it. So yeah, what is the complexity? You can kind of see that for each digit we just go through this assortment of if statements and only addition. So this is going to be linear time. Yeah, and in terms of space, as I said, this is going to be linear space, but you can actually reduce this to all of one space by keeping by noticing that we only look at the current we look at 2 digits, but we only look at also previously two counts, right? The DPs of index and DP of index -1. And as long as you're gonna do a cascading type thing in a very smart way, similar to Fibonacci, you could get it to all one space. I'm going to leave it as an exercise at home. I'm going to make this slightly smaller so you can see all of it very briefly. But that's all I have. Linear time, linear space, but you can reduce it to all one space trivially or easily. You can also look up my space optimization video. I also have done space optimization problems in the past, so maybe check into that. That's all I have for this one. Let me know what you think. Stay good, stay cool, have a great weekend, and to good mental health. I'll see you later. Bye-bye.